Hello and welcome to section 1.1 of pre-calculus. This is equations of lines, and so here are the three different forms of the equation of a line. Now I'm going to talk you through these and explain why we have three different forms, and also explain the usefulness of one versus the other. Now all of them are fine ways to write them, write an equation of a line. Some teachers prefer different forms over the other, but we're going to kind of talk about these. So the one that you're probably most used to is the slope-intercept form, where m is your slope and b is your y-intercept. And this is really good for graphing the equation and seeing where it looks, what it looks like on the graph. So that's one of the benefits of this one. Down here, one that you may have seen before is standard form, and in standard form you'll notice that in the equation you see no slope. You see no slope, but you'd solve to find the slope if you needed it. And now you're probably asking, well, why would I use this equation if I had that if I had the first one up there? Well, this one has its benefits for graphing y and x intercepts. Graphing, oops, I should put graphing. Graphing y and x intercepts. So it has its advantages, like you could, if I put 0 in for x, that would get rid of the ax part, and then I could find the y-intercept. If I put 0 in for y, I could find the x-intercept, and that's one of the powers of standard form. Then finally there's point slope, and in this one, this is one that we use all the time, especially in calculus, and this is a way you can leave your answers in calculus, is that again, m is your slope, and now x1 and y1 are a point that the line will go through. So you don't have to solve it for y equals mx plus b. You could just plug in the y value of the point, the x value of the point, and the slope, and you have the equation. Now, this equation can be turned into slope-intercept form, and slope-intercept form then can be turned into standard form, which I will demonstrate on the next slide. Point slope, though, is probably going to be new to you, and if it isn't, great. If it is, make sure you have all three of these equations, because we're going to go through them. So now we want to find the equation of the line that passes through the given points, and it says find all three forms. So first thing we need to do is we need to find the slope of the line. That's for the two of them, we need the slope. So we might as well find the slope first. And if you remember, the slope is change in y, the rise, over the change in x, or the change in the run. So I'm taking my 2 points and subtracting them from each other. And now it doesn't really matter which x or y you choose first. You just have to pick one, and then the x value that goes with that y value goes first. So I'm going to pick this 6 value for y because I like to subtract positive numbers. So when I write this, I'm going to write my slope as this 6, there's my y, and this 0 is y1. So it's going to be 6 minus 0 over my x value. So now that I chose 6 to be my y, that has to be my x, and this 6 has to be my y1. So it's going to be negative 3 minus 6. Now you'll notice that the ordered pairs are stacked on top of each other the way they match up, and so now if I subtract these, I get 6 over negative 9, which I believe if I divide by 3, I will get negative 2/3. Now you may be wondering why I moved the negative to the top. It doesn't really matter. As long as there's one negative in there, it doesn't really matter where the negative sign goes. So now I've got the slope of my line, and to write the equation, I'm going to write point slope first because I'm at that point slope. And point slope will be found, I've got the slope, which is right here, negative 2/3, and I can pick either one of these points and you'll get the same thing. So I'm going to pick this guy right here just so that I don't have any zeros in it. And well, I'll do both of them, and I'll show you why in just a second. But I'm going to say y minus y1, which in this case is just a different y, so I'm going to use 6, equals negative 2/3 times x minus negative 3, so that's going to be a plus 3. So there's a point-slope equation. I could have another point-slope equation, either one, and use the other ordered pair, and that would have been y minus 0 equals negative 2/3 x minus 6. Now the benefit for this one over here, the B one that I chose, is that it's going to be much easier for me to put it into slope-intercept form. So now slope-intercept form will be my next one. And so what I would do is take the point-slope equation and solve it for y equals. So if I take the first one here, if I take a, and that would be y minus 6, and I'm going to distribute the negative 2/3 to the parentheses, I get negative 2/3 x, and negative 2/3 times 3 becomes negative 2. And at this point then I'm going to add the 6 across the equal sign, and I end up with y equaling negative 2/3 x plus 4. So there's my slope-intercept form. Over here it would look the same, except for I don't have to add for part B over here if I was going to use the second equation. So just to show you that I end up with the same thing, I don't have to subtract 0, so I'm really left with y equals, and if I distribute my negative 2/3, I get negative 2/3 x, and then a negative times a negative gives me positive 12 over 3, and 12 over 3 would be 4. So when I distribute, I ended up with the same equation either way, so it doesn't really matter which point you pick, you just got to pick one and plug it in. And then from this point, we can go to standard form, and standard form is basically taking the point-slope equation, or slope-intercept form equation, and making it so that there are no fractions and the x and y are on the same side. So if I have the equation, my slope-intercept form of negative 2/3 x plus 4, I need to move everything away from the number, so I'm going to add 2/3 across the equal sign. So I have 2/3 x plus y equals 4. So my final step to get it into standard form is to get rid of the fraction, and that would be to multiply the whole equation times 3. That will remove the fraction, which will give me 2x plus 3y equals 12. So this is standard form, and remember, standard form is good for graphing the intercepts where it crosses the x and y axis. Slope-intercept is a good way, we're used to graphing it, and point-slope is probably the quickest way to get the equation of the line. So it just kind of depends on how you want to do these, but this is something that we're going to be doing in class. I don't know if we'll go through all three forms, but I just wanted to show you how all three forms were related to one another. So then we want to talk about parallel lines and how lines are parallel. Well, if you remember from algebra, geometry, algebra 2, basically parallel lines have the same slope. So if we can find out if they have the same slope or not, then we'll know they're parallel lines. So we're asking, are any of these lines parallel? So I just need to find the slopes of each one of these lines. So if I write it in slope-intercept form or point-slope, I should have a pretty good idea what the slopes are. So to get this guy into slope-intercept form, I'm going to divide everything by 2. So you can see that the slope-intercept form equation is y equals 6x plus 5. All right, so the slope in this case is 6. Over here, if I was to write it in slope-intercept form, then I would have to say y equals 0x plus 6. Now remember, there's no slope of this line because at y equals 6 is a horizontal line, and all horizontal lines have 0 slope, so there it is. So in this case, there is a slope of 0. So A and B are not parallel to one another. So finally, down here, you can see in point-slope form, 6 is my slope, so I don't need to do anything for this equation. So I know that lines A is parallel to line C. And I guess I probably shouldn't say line. Line A is parallel to line C is really what we want to write these as. That's what we're trying to figure out because they have the same slope. So then, with perpendicular lines, you may or may not remember this, but the slope times the slope that is perpendicular will get you -1. Now that may or may not mean much to you, but basically the perpendicular slope is equal to -1 over the slope. So it's basically flipping the slope over and changing its sign is what this is telling me. So if we want to find an equation of a line that is perpendicular to line A, and here's line A, and goes through this point, then we need to find a perpendicular slope first. So there's a couple ways you could go about this. I have my slope. Hopefully you can see that my slope that I'm dealing with in A is 2. And so if I want my perpendicular slope, I could say, oh, well, my slope is 2. If I multiply that by the perpendicular slope, I would get -1. So if I divide by 2, my perpendicular slope will tell me it's -1/2. Another way to look at it is just to flip this fraction over. The slope fraction itself is 2 over 1. Flip that fraction over and change its sign. And that's really what's happening. So, but the best bet is to just kind of think of this equation right here. Think of the given equation at the top and solve for your perpendicular slope. So now my perpendicular slope for line B is -1/2. So I got y equals, well, actually, I'm going to write, it doesn't say how I need to write my equation, so I'm going to go to point slope because that makes my life much easier to start with. So remember, point slope is y minus y1 equals m times x minus x1. Well, if my slope is -1/2, because that's the perpendicular slope, my y1 is -7, and my x1 is 6, I can just plug those guys in, and I'll have my equation. So y plus 7, because it's the opposite of what we see up there, equals -1/2, and then x minus 6, opposite of what we see. So now this is a fine equation. This is a good answer. If you prefer to go to point slope or slope-intercept form, we could do that real quick. I'd say y plus 7 equals -1/2 x plus 3 when I distribute the 1/2, and then I need to subtract 7 from both sides, and so y equals -1/2 x minus 4. Also a good answer. So either one of these will be acceptable for the equation of the line. It doesn't really matter whichever one you want to do. Some people are more comfortable with the slope-intercept form because that's what you're used to, but point slope is the exact same thing. So I believe this concludes our lesson for today. So if you have any questions, please come to class prepared to ask them.